Hello all. Uh, we have this problem with us today. Let us see. First of all, what is being said in the problem, right? So there are some amount of metals. So there are what type of metals? First of all, there are iron, aluminium, right, and copper, right? I'm just using the symbols. Iron would be Fe, but okay, let it be. It doesn't matter. First of all, this is 405 cc. This is 783 cc. And this is 351 cc that is available. Now we are making cylindrical shapes out of them, solid cylindrical shape. Now let me show you cylindrical shape, right? Circular cylinder. Okay, so this is a cylindrical shape. Okay, this we are making out of this amount of metal. Now first things first, what is the area of this cylinder? So let us say this height is h and this radius is r. Okay, just so we know, the volume is defined by very easy. First of all, area of the of this, right? Area of this, so that is pi r square into height, right? That is pi r square h, right? That is very straightforward, right? That is the volume. Now let us say what is the area. Area would be simply, area means surface area. First of all, how many circles are there here? So you see there is a circle here as well, and it has also some area. First of all, that would be pi r square, this pi r square, and this pi r square, right? So both of them together it will be 2 pi r square, and plus what is this? This area, right? So I'll draw this wavy things here. This surface area. What is this? First of all, the circumference of this, circumference of this. Okay. Let me do it again. Circumference of this, that is 2 pi r into height, right? That is h. There is no need to remember all this stuff. Okay, you can just create the formula on the go. Okay, if you practice a little bit, it will be very fast for you. So these are the two formulas that you will remember. Now let us get back to the problem. Okay, what does the problem say? Again, there is iron, aluminium and copper. We are making cylinder out of them. There are many cylinders, but all the cylinders have same volume. That is a key thing, right? They have the same volume. Okay, and they have the radius r, sorry, 3 centimeter, right? So if we have to make the volume, what is the formula of the volume? First of all, formula of the volume is pi r square h for each of the cylinders, right? So it will be pi into r square is 3 square into h. We don't know the height, so we'll take it as h, right? So that is the volume for each of them. So that is 9 pi h. Let us say we have n1 of this iron, n2 of aluminium, and n3 of copper. What are n1, n2, n3? Number of cylinders made. Okay, number of cylinders. Now we can say that for this it will be 9. Total volume of all of them would be 9 pi h n1, right? For this it would be 9 pi h n2, and for this it would be 9 pi h n3, right? All right. Now you see 9 pi h n1 is simply 405. This is simply 405, right? This is equals to 405. This is equals to 783, and this is equals to 351. So we'll have h n1 equals to 405 by 9 pi, right? That would give you 45 by 9 pi. I will write it in different color so that you don't get confused. This is 45 by 9 pi, right? Similarly, we'll have hn2. hn2 is simply 783 by 9 pi, right? So if you calculate this, it will come out to be 87 by pi, right? Similarly, your HN3, this is HN3, would be 351 by 9 pi, right? 351 by 9 pi. And if you calculate this, it will turn out to be, I'm just writing it here. I should have planned this better actually. But anyway, this is 39 by pi. Okay. All right. I will write it again. So HN1 is 45 by pi. HN2 is 87 by pi. And HN3 is 39 by pi. Okay. All right. Now you see N1, N2, N3 are integers. N1, N2, N3 are integers. And we have another very important for important information that is given. That is the total number of cylinders is to be kept at minimum. Now see you this has become a GCF problem. LCM and GCF, greatest common factor, is this problem is that. So we have to find the greatest common factor of 45, 87, 39, because then only we can keep the number of cylinders to be minimum, right? So GCF, if you calculate, this will turn out to be 3. There is no greater number than 3 which divides all these three numbers. Okay. Now we have this, then we can say that H is basically H is basically 3 by pi. Okay, because if we divide this 45 by pi by 3 by pi, you will have n1 as 15, which is an integer. Okay, all right. We have, so then now what are the information that we have? R we have h by pi, sorry, 3 by pi, sorry, r we have is 3, that is given already, right? Because radius is 3 centimeters, so r is given, h is 3 by pi. Now we can calculate n1 to be 15, n2 is simply, we will calculate it from this formula, n2 is simply 87 by 3, right, which will turn out to be 29, and n3 is will turn out to be 39 by 3, that is 13, right? So total number of cylinder would be n1 plus n2 plus n3, right? This will come out to be, first of all, 15 plus 13 plus 29, right? So this is 57. Okay. So all right, we have n. Now we will go back to our formulas. What is being asked? The total surface area of all these cylinders. Now we have, for each cylinder, the total surface area is this, right? Surface area is this. Now for n cylinders, it will be 2 pi r plus h into n, right? Now it is simply the matter of substituting the numbers. So r is 3, all right? Now this r is again 3, right? What is h? H is simply 3 by pi, okay? And what is n? N is simply 57, all right? So you have to just calculate it. So it is very easy. It is, if you calculate this, it will turn out to be, first of all, this is 18 into pi plus 1, okay, pi plus 1 into 57, and this will be 1026 into 1 plus pi, okay. So this is the solution, and this is how you go about this type of geometry problem. Okay, hope you liked the solution, hope you understood what was being said, and it's adds some value to you. Like and subscribe if you would like to, helps me a lot. See you in a new video with a new problem. Okay, thanks for watching.